Hello, hey everyone. Hello. Hey Pradyumna, hey Muthu, hey Tulrose, hey Raghu, hi Manish, hi Raghav. Okay, so apparently Pradyumna is fighting for who did certain things first. Interesting. Hi Shubham, hi Mayank. Mayank, by the way, we also have to catch up to solve your issue. I forgot. I am back to work, so we can discuss anytime wherever you want to. Hi Yazir, hi Abhilash. Hello everyone. Let's wait for another 2 minutes for other folks to join. And for the first 5 minutes, I'd like to probably just discuss the logistics and then we can start the class. Let me share my screen and see if the writing technology that I'm using is okay, if it's working or not. Let me know. Okay, so I'll just probably write something. Maybe I'll just say couple of logistics. Is my writing clear? Is the font size legible? Is everything good? All right. Hi, Dilreet. Hi, Dilreet. Great, great, guys, great. Another 1 minute and we can then probably just get started. Just to give an idea, if in case you guys are wondering, today, although it's a remedial class, but we'll cover everything from scratch because there were, yes, in the last class, there were lots of technical issues on my end. So the class flow wasn't great, wasn't smooth. New games for today. Well, I mean, I didn't get enough time to sort of create another new story, honestly speaking. So we'll probably repeat some games, but then I'll try making it somewhat interesting. A bit of changes here and there, but yeah. Uh, your screen and video share is blank. Can somebody confirm if others? It's fine, right? It's fine. I feel it's fine. Cool, perfect, perfect. All right, so guys, it's 9:05, and I think I would like to discuss a couple of things related to the logistics. So first thing, over the weekend, we receive a lot of feedback. All right, now there were feedback majorly related to assessments. There was second feedback related to pace. Third feedback was related to content. I would say content quality. And the fourth feedback was related to the instruction or essentially the instructor. All right. Now, coming to all of these things first, I think assessments, I believe you might already would have started seeing some changes. One, we are trying to revise all our questions and checking if they are aligned with the lectures or not. All right. Second, we are trying to work on our tech. How can we make the tech system more aligned for DSML setting? So this, I would say, would take some time. All right. And I hope you have seen that the Scalar team is very proactive in terms of making the changes, in terms of working on the feedback, and we will try working on the tech as early as possible. All right. Third thing, I personally will be solving all the questions before it gets assigned. So if I am unable to solve any question, or if it is taking me a lot of time to solve a question, we'll try either diluting the question language. All right. So maybe we can work on the language. Maybe we can assign a different question which tests the same logic, but it's not as difficult to understand. All right. And we may also add or delete certain questions based on what is the plan for teaching. All right. So I will personally look into solving these questions one by one. I will solve all the assessments, be it normal assignments, be it MCQ questions, everything. All right. Just give me 1 second, please. Okay. All right. Any doubts in here? Everything related to tech, don't worry, we'll have everything in backend. So if there are some issues related to scoring, those will be figured out. Don't worry about it. As long as questions are in working form, it's okay. Also, we'll have our discussion slash doubt clearing sessions with Mohit, or probably me, most likely Mohit, every time we have some questions. All right. So assessments would be solved. I know it's your batch is one of the few first iterations. There will be errors. Nothing is perfect in their first go. The DSA module took some 20-30 iterations to get in the condition it is, but we'll make sure that your doubts, your questions are resolved. All right, we'll make sure. Cool. So related to pace, I think there were apprehensions. Let me just probably. So related to the pace, I think mostly the concerns were DSA versus DSML. All right. And within this, there were questions related to how class is considered. So I think although you have all the rights to compare DSA and DSML, those students who are coming from DSA, all right, and have learned, have gone through intermediate and beginner batch, you have all the rights to compare DSML and DSA. But let me take 2 minutes to understand where it might not be a right criteria to compare DSA and DSML. So first thing is the content. All right. So I would say the time duration for DSA module is what? Somewhat 2 months, if I'm not wrong. All right. And that also is basics, very basic stuff that you've done. I don't think you would have done something like trees or graphs or maybe dynamic programming, nothing. The whole idea is to make you comfortable with programming. The whole idea is to give you conceptual knowledge of data structures and basic things which would be required for you to know even as a data scientist. All right. Whereas DSML content is 7 months long and the syllabus that we have is literally 10x. All right. Now you may say that this is not our problem. All right. We are trying to fix this up and we're trying to see how can we add more and more content here. How can we cover everything? Although I can ensure right away that the coverage will be much, much, much better than all the competitors, but we'll make sure we discuss what matters. We'll make sure we'll discuss everything what matters. You wouldn't find any problem, not just with the interviews, but also when you'd be working as data scientist. All right. Second thing is related to whether class is going smooth or not. All right. So I have a couple of things to say here. First thing is DSA is very conceptual. All right. And whatever was not conceptual there, for example, programming or how to write a particular algorithm wasn't covered there. All right. Now that was intentional because we really wanted to focus on conceptual part, and you could have easily gotten more understanding of programming. All right. Second thing, if I remember correctly, if I've seen the right videos, we've spent so much time in DSA that we spent close to half an hour on just talking about ASCII. I watched the string videos. We spent close to half an hour just talking about strings. So while talking about this part, which is the 10x thing, and also making sure that we cover much more than our competitors, and also cover everything in 7 to 8 months, something like this is technically not possible to carry out in DSML, because just simply the vast of things, the things that will be covering in DSML is a lot. What we can do for other batches, maybe we can trim down the time duration for DSA, and maybe discuss what matters only for data scientists there, and maybe we can increase the duration for DSML. All right. What we can do for your batch, maybe we can simply increase the DSML by 1 or 2 months. All right. We're still trying to figure out who all would be fine with that. But yes, we will make sure that we cover what matters most definitely. Yeah, so Sri Ramya, we'll talk about this. We are like working on taking those feedbacks. I am just telling you what all we have been looking into. All right. Now, other thing was related to the smoothness. I am very sorry to say that DSA is very conceptual. Again, it looks like, you can sit in the movie and just enjoy it at a slow, smooth pace. Well, that was intentional to give you more comfort and get the idea of get habitual to the system in classes and assignments and whatnot. DSML is very exploratory in nature. All right. Now here, if we spoon feed you, if we actually tell you everything, if we give you enough practice, I am sorry, you can't become a good data scientist unless and until you tackle certain challenges by yourself. All right. We can very easily create everything, pack everything in the lecture, don't give you anything. I am sorry, the minute you would come across something different in the interview, you would fall off. You would totally fall off. All right. Now, why you don't fall off in DSML, DSA? Okay, software engineering has been, I would say, a field for almost 2 decades. Now, most of the interviews, most of the companies have very, very structured programming style, interview style. Whereas for DSML, even until now, no company has any structure. All right. The kind of questions you would be asked, the kind of rounds that you would have varies a lot across all the companies, and even for different positions in different field. Now think about having lesser time, covering 10x content, and then still tackling the exploratory part. All right. We cannot provide you an easy breathy lecture. We'll try making it as structured as possible, and I'll try from starting today itself. But please don't expect everything to be nice and as smooth as DSA. All right, that was a phase. We're probably trying to work it out again, because I think a lot of you have gone very comfortable with the idea of doing things at a slow pace, and in a very, I would say, conceptual movie like format, like you sit and enjoy. Okay, so these are things related to the content quality, and we will try ensuring that the classes are really structured, the assignments are aligned, so that the extra efforts that you're putting to figure out these things can be minimized. I cannot promise that they can be figured out very quickly within a week itself, but I am sure that you trust that we are good with taking actions. We'll take all the feedback constructively. Nobody's getting offended. Nobody's feeling that you are not giving us right feedback. As long as you give truthful, unbiased, and constructive feedback, we are happy to work on it. All right. We are also providing you business case discussions every week. All right. Now, we would want you to probably spend a lot of time just figuring out things by yourself. And if you cannot figure out, maybe this is the time for you to understand how to do it better. All right. And believe me, it will take some time. It may take weeks, it may take months, but learning by doing is what is the preferred way in data science. All right. We don't want you to look at the solution right from day one, know how to do it. Do it by yourself, try, follow, and we are there to help you out, to make you, to help you understand how to do it better. All right. Second thing, we'll have our doubt resolution session. I think I've discussed it. And then we have scalar research program, all right, which might actually be a proper program later on, but you are not being charged for anything here, all right. We are trying to work it out and give you more ideas so that the kind of problems that you've faced as a part of beginner, or I would say one of the first few batches, we want you to take the benefit out of this program so that you have an edge over your competitors in the market when you'd be applying for the placements. I just want to make sure that that you are aware that this research program would probably not be part of scalar data science later on. It might be a paid course and probably much higher value as compared to other things. We are working on it, so I cannot give anything related to research program. I might take research related classes if you are interested in computer vision, because that's my forte, that's where I do my research. That's all I know. Okay, so if there are no questions, I'd like to tackle the last beast here. All right. So the last thing, I think, which had questions is related to the instructions related to the class. All right. So first thing, I would like you to, I mean, if you are giving feedback, one is the feedback related to content. All right. Now there are 10-15 people who are involved in content development, which includes a lot of top data scientists from industry as well. So if we are not making something a part of the lecture, there is a reason. Either it can be the cognitive load, all right. There is absolutely no benefit of telling you 25 different NumPy functions if you cannot remember them. There is absolutely no benefit. Okay. So if something is not part of any lecture, and if it is important, we'll make sure that it's a part of lecture in the coming classes. We'll make sure that. All right. So content coverage, don't be worried. Content style, maybe this is something which will keep on improving. So we would like that you provide more and more feedback here to us so that we can improve the quality of the lectures more and more. All right. Second thing is the instruction. All right. So I am following all the content that we've decided. I am not even saying a single sentence which is not part of what is decided. And that's gonna be the same so that the quality check is maintained. When it comes to instruction, there might be follow-ups. For example, what happened in the last class, simply because the content had some problem. All right. And we'll try focusing, we'll try ensuring that it's not the case, it's not happening more and more frequently. That is something I will ensure personally. Okay. Instruction, I think I received feedback related to using the technology. So I'm gonna spend a lot of time probably making myself more comfortable with the tech, be it my iPad, be it my monitor, or simply just way how class is structured. And I feel within 2 to 3 weeks, or I would just 2 weeks, I think you would see an improvement here with the tech. Related to explanation, I have not received, I would say we have not received any specific complaint here. I think explanation, what we've observed from the last batch, things are going better. Related to be able to solve certain doubts, I think most of you would agree that I am very proactive with solving the doubts. I try my level best. and I end up being sometimes honest as well. And from the honesty, I would tell you that I have not used it personally, and I would only say that I have not used it personally because it's not important. Most likely, if I've not come across something, there are 80% chances that it's not as important to be answered or to be a part of the lecture. All right, that I can assure you. And if even if I feel that I don't know something, I can ask you to look into the documentation, because there are millions of functions in Python. Nobody, literally nobody, can remember everything. I am sorry, I cannot remember all the arguments of all the functions. And I may ask you to look into the documentation and probably discuss it. All right. Probability class, I agree, that was a disaster. I think there was a bad example. I got lost, and the confusion was not. There was a confusion, and I was majorly struggling with the tech. We'll ensure that the probability class is structured as well. Now, I'm going to take another 2 minutes to take up any doubts before we start. We have enough time. I'll ensure that the class ends at the right time. Also, from the next class, not this class, I'll ensure that we have some 4 or 5 engaging quizzes. We take a dedicated 5 minutes break at 10:30. Okay. All right. So this would also help you making the class experience would be I would say smoother. All right. Quizzes are great. Yes, we'll ensure that there are some interesting quizzes from the next class. Not today. Not today. We'll ask questions. Today I haven't prepared tough questions from the quizzes perspective. All right. And I think all of these changes would come incrementally with time. Things cannot change in a day, but I hope you appreciate the fact that we care about whatever feedback that you're giving, and we'll keep on working on it. Siddharth, we'll discuss towards the end. All right. Okay. So no, I believe no questions. No questions, I believe. Great. Last thing I would say, I think in Haphazard, suddenly because you guys were not able to solve the assessments, there were some issues. You felt the content is at surface level and the classes are not going well. I think there were 1 or 2 people asking for the change of the instructor. Give it time, give it probably a week or 2 weeks. Let's see that if the total experience is getting improved or not. I will personally look into it. And if you still cannot trust thing, if you still feel that probably a better instructor can do a better job, I myself would be more than happy to escalate this issue very quickly, because the success of DSML program in general is what matters to me, not specifically whether I am teaching or someone else is teaching. All right. So feel free to reach out to me. Even if you say on my face that I'm not liking how you're teaching, I will escalate that process. Don't worry. All right. Okay. So I believe there are no questions. So I'm gonna start the discussion by discussing what is today's agenda first. All right. So as we were doing in the last class, we were discussing, we started with one game, which is cups and money. So we had money in one of the possible cups. Yesterday, we discussed 2 variants. In today's class, we'll actually work on 3 variants. All right. So the third variant, which we'll add, is called Monty Hall. All right. And I'm gonna explain a naive method to solve it. All right. Which is something that you might come across most of the times. And I would also tell you that this is not the best way to solve it. And later we'll do something called Bayes' theorem, which can actually give us a structured approach to solve the Monty Hall problem. All right. We'll discuss what is probability and why, specifically from data science perspective, probability is important. While discussing probability, we'll discuss experiments. We'll discuss different kind of experiments, random and deterministic. We'll take up their examples as well. And we'll discuss how to find a sample space for an experiment, how to figure out what event you're interested in, how to calculate probability for that event. We'll also discuss the general formula that you have been used to using probability for solving probability and where it is not applicable. All right. And what to do when it is not applicable. We'll discuss all of this. All right. Now the second game will remain same. Whatever we discussed in the last class, we'll throw a die and we'll do a couple of experiments. So first thing we'll do is we'll learn laws of probability very quickly. I don't think it's very difficult. Second thing we'll do is something called experimental or empirical probability. That is something also we've looked at earlier, but we'll look into the details again. All right, and how, let's say, it's different from the probability which is discussed earlier in our game one. All right. I'll bookmark. I'll bookmark as well. No worries. I'll bookmark. Game 3 cards. Just remind me if I forget. I'll just say that I'm bookmarking. Remind me if I forget. All right. So the third game will be on cards, and I think this discussion will start with discussing about multiple events. All right. So sometimes we might be interested in discussing and seeing multiple events happening together. All right. So we'll start the discussion with this. We'll discuss compound events. We'll discuss joint probability, marginal probability, and conditional probability. And we'll ensure that none of us, including myself, gets confused in this. All right. And then we'll tackle the biggest beast out there, I think, which a lot of people have difficulty. So we'll together try understanding how can we try not getting confused. Everyone gets confused. I gets confused. We'll try finding some thumb rules to figure out how can we deal with mutually exclusive events and how can we see if events are independent or not. All right. Last but not the least, we'll discuss game 4, which is where we'll discuss about some faulty machines. We'll discuss something called law of total probability, basis conditional probability and law of total probability, equation 1 and equation 2. We'll figure out something called Bayes theorem, which is very, very important. I would say the most important topic. We'll also discuss its data science application and why it is very important. And finally, using Bayes theorem, I'm going to solve, I'm going to tell you a better way to solve to reach the same conclusion of the Monty Hall problem, which is what we started our lecture. So I'll conclude finally with the same problem that we'll start with. All right. Is there any doubts or anything? I think this would be a lot to cover. So let's get started. And other doubts besides these topics, I'm going to cover later in the Q&A session. All right. So let me start with the motivation and let me add my first bookmark. I would say probability introduction. All right. So as a part of probability, let's start with game 1. What was game 1? It was money in cups. All right. This was the game, and I'm not going to spend a lot of time because we've discussed this. All right. So we have a variant 1 of this cup. All right. Of this game, where we have how many cups? We have 2 cups. All right. And they are upside down. So we have 2 cups, and there is money present in one of the cups. Let me say money or like some diamond or whatever. All right. Then we have variant 2, where we have same cups, but we have 100 such cups. All right, we have 100 such cups. All right, and again, there is some price present in one of the cups. All right, now the question that is there is, which one would you choose? Which game would you like to choose? All right, now it depends on multiple things. All right, first, what chances? Where are the chances of winning more for me? All right. Second, reward. All right. Where am I getting more reward? All right. So in terms of chances, if I see clearly, even if we don't know the formula for probability, all right, we can clearly see that here the chances would be more. How much? Exactly 1 by 2. Correct? What would be the chances here? The chances here would be 1 by 100. Correct? So I can see clearly that the variant 1 is better than variant 2. All right. Okay. So let's talk about the reward. Let's say that in first case, maybe I am in the first variant, I am putting up $10. All right. In the second variant, I'm also putting up $10. All right. What do you think? Which game would you like to play? Answers in the chat. Which game would you like to play? Clearly, chances of winning is better in variant 1 and the reward is same. All right. Clearly, we can choose variant 1 over variant 2. All right. Now let's look at another variant here. Let's say in the first case, I still keep $10. And in the second one, I put $100 instead. Which one would you choose? Okay, so mostly a lot of people think still variant 1. All right. Okay, cool. Well, the answer is correct. Let me just take out some time to explain. So first thing, a naive person would think that the chances of winning a higher sum, a higher value is more in what? In variant 2. All right. Now, someone who has more risk appetite would probably want to choose what? Second variant. Why? Because the person says that although it is less likely, I might actually win $100. Whereas if I choose variant 1, I might just end up at max earning how much? $10. All right. For someone who thinks, and hear me out, someone who thinks probabilistically, all right, what do we mean by this? They basically try to understand the chance game. All right. They try to understand what is the expected value I am supposed to get here. Now, I am not getting into expectation. All right. It's a part of a different lecture. But here, if you see, the chances in variant 1 to win is half. All right. And the money that is what we have is what? $10. All right. So at an average, you have a chance of winning $5. All right. At an average. What does it mean? If you actually play this game, let's say large number of times, at an average from any game, you would earn how much? $5. All right. Second case, you have a chance of 0.01 in winning here. All right. But you can win $100, which seems like a big amount. No, not a big amount, because still the expected average amount that you'll earn from any game would be $1. So let's say if you perform this game 1,000 times, here at an average you will earn how much? $5. All right. Here at an average you will earn $1. All right. So which one would be preferred? Still variant 1 would be preferred one. All right. And this leads me to the conclusion of this talking about things probabilistically. All right. So there are certain experiments, I would say. What are experiments? Anything that you perform which has some outcomes, all right, which will have some outcomes, is considered an experiment. All right. There can be two different kinds of experiment. First, a deterministic experiment. How many outcomes are possible for a deterministic experiment? One only. Consider adding 5 plus 3. If somebody asks you what is 5 plus 3, if you do it once, you'll get answer 8. If you do it 100 times, you'll get an answer 8. All right. Why? Because the only possible outcome is 1, right? Why it's called deterministic? Because it can be determined that, okay, there'll be certain answer and it will be same all the time. It will be what? It will be same all the time. All right. Now let's talk about random experiment. All right. Why do we call it random? Because it has multiple possible outcomes. All right, it has multiple possible outcomes. We don't know what will we get when we roll a die, whether we'll get 1, whether we'll get 2, whether we'll get 3, 5 or 6. All right, we don't know. All right, now if you are interested, what are the chances that I will get 1? All right, what are my chances that I'll get 1? It will be what? 1 by 6. All right, now does it mean that in one of the 6 cases you will get 1? No, not necessarily. But this is how, at an average, if I perform this experiment multiple times, chances are in one of the 6 cases I might get 1 by 6. Now probability is just a way to, I would say, explain uncertainty, or I would say explain randomness. All right, when you don't know what will be the output, what will be the final outcome, you can probably talk about its chances. All right, what are the chances of having certain outcome? Why? Because we would like to take an informed decision. All right, we would like to take an informed decision. Now this decision might actually break, this decision might actually change if the reward value is $1,000 here, and you understand probably why, right? If the value is $1,000 here, you might rather want to play this game. All right, why? Because probabilistically thinking, the chances of earning at an average becomes much more higher here. And of course, there is a big chance of earning the higher amount if you by chance end up being lucky. All right, so I think it's a win-win situation. Any doubts in here? Any doubts? Why do we use probability, and why are we talking about probability as a part of data science course? Because we will be doing a lot of predictive analysis in data science. All right, what is predictive analysis? You would like to predict. All right, can anyone predict the future? Possibly no. Can someone probably tell something about uncertainty? Let's say some future value can be, maybe let's talk about weather. All right, so the next day can be sunny, it can be, let's say, snowy, it can be rainy. All right, maybe I cannot tell if it's going to be sunny, it's going to be snowy, or it can be, let's say, rainy. Can I still tell what is the chance of it being sunny, what is the chance of it being snowy, and what is the chance of it being rainy? All right, and data science is all about predicting chances. Now whichever has higher probability, data science or machine learning model will say, okay, this is the final prediction. All right, with some confidence, of course, the value needs to be high. Sorry, I'm not looking into the comments. I think Sumit and Raghu are mentioning multiple things. Let me read very quickly. But in real time, probability matters, like ITM versus ATM or OTM in option chain. Okay, if you play variant 1 10 times and win. Okay, I think you guys are not asking question and probably just adding more to the discussion, some value addition. All right, cool, perfect. All right, so here we're trying to take an informed decision when future is uncertain. All right, that's the reason we are talking about probability in data science. I think if I talk more about it, it will be an overkill. I think you pretty much have an idea why we're talking about probability, decision making, risk, reward, everything. All right, I think this is pretty basic. All right, so very quickly, I think I've discussed experiment. So experiment. What is an experiment? Anything which has possible outcomes. All right. Second thing, what is a sample space? All right. So what is a sample space? All the outcomes, all possible outcomes is what is called a sample space. All right. Let's understand this a bit more. using Venn diagram. All right. So I'm going to make one Venn diagram for probably tossing a coin. All right. Tossing a coin. This is a coin. Sorry. So we have heads and tails. Can we have some other possibility? No. In one experiment, we'll either get a heads or a tail. Now, I am not talking about the cases where the coin won't land properly or it will land vertically. Let's not talk about those cases. But let's say the possible outcomes here is heads and tails. All right. Let's talk about another example here. Maybe rolling a die. All right. Rolling a die. All right. What can be the possibilities? We can get 1, we can get 2, we can get 3, we can get 4, we can get 5, and we can get 6. All right. So this is what is called a sample space. Now, what is an event? All right. Now, event is what you define. All right. Now, here, the event that you might be interested in is getting a heads or getting a tail. And if it is a compound event, you might be interested in getting 2 heads. You might be interested in getting 2 tails. You might be getting interested in taking a specific pattern, a heads and a tails, or tails and a heads. All right. Here, you might be interested in knowing the probability of either getting 1, 2, 3, 4, 5, 6, which is a bit obvious. You might also be interested in probably knowing the probability of even number. All right. So what are the even numbers? Maybe I would say this makes even number. All right. You might also be interested in probably getting odd numbers, or you might be interested in probability of, let's say, what is the probability of getting a value higher than 3 or equal to 3. All right. What would be that? That would be probably this. All right. So in terms of sets, if you notice, I think what I'd like to say is, first thing, we can denote this with an S. An event can be denoted with E. All right. Now, what we can see from this discussion is an event will be a subset of the sample space. All right. Purely from the set point of view, you can clearly see that an event is a subset of the sample space. All right. So what would be the probability of getting a sample space? What if I'm interested in knowing probability of the sample space? Okay, please leave some line in the break, else when notes are covered into PDF text. Okay, I'll ensure. So probability of getting the whole sample space is 1. Correct? Okay. Any discussions? Any doubt? Any doubt in here? Anything? I am trying to go slower, just to cater to general needs. But any discussions? Any doubts you have? All right. So if this is clear, I'm going to formally introduce the probability definition. All right. The definition of probability. All right. Which you've been hearing probably from your class 6th or 7th. All right. So if I want to calculate the probability, I'm going to look for, I'm going to look for total number of outcomes. I would say total number of outcomes. All right. What does total number of outcome means? It's essentially means number of outcomes in the sample space. All right. Here, I'm going to say, I would say number of desired outcomes. All right. What are the outcomes I am interested in? All right. So I might be interested in possibility of getting an even number, which is what? 3 out of 6 in the case of rolling a die. All right. What are the total outcomes in this case? 6 possible outcomes. All right. Now, is this definition always applicable? Is this definition always applicable? All right. No. This definition is only applicable. This definition is only applicable when outcomes are equally likely. All right. Now to explain what does it mean. All right. Let's take an example of a matchbox. All right. So I have this matchbox. all right? And there's just a bit of weird game that I want to do. I want to just like the die, I want to roll this matchbox and see what comes on the upside. All right. Now clearly an edge face can come, all right, or this long of an edge face can come, or a proper face can come. Correct? All these three possibilities are there. Now, if you actually see, there are one or two big faces. All right, let me call it big face. There are, I would say, one and two long faces, and other two are the short faces. Now don't go with the names. These names are not standard one, I've just made it up. All right, but if you see, all of these faces have equal number in terms of frequency. So there are two big faces, two long faces, and two short faces. All right, are they equally likely? Are these three events equally likely? No. Why? Clearly depends on the surface area, right? The physics is such that this event, the probability of getting a long face is much, much lesser than probability of getting a big face, correct? All right. So we will discuss later how to carry out this discussion. Here you'll probably have you'll need to perform some kind of experiment to understand how likely is this phase as compared to this one, and we'll take such an example. But the whole idea is that this formula, the standard formula, won't be applicable here. All right, this standard formula won't be applicable here. Any doubts? So here the outcomes are not equally likely. So if you are solving a case, if you are actually using this formula, make sure, not the best color that I used, still learning. So if you are trying to use this formula, make sure all the outcomes are equally likely. All right. Perfect. Let's take up an example, probably right away, and try understanding how would you solve this. All right, and then maybe after that we can just conclude this thing with laws of probability. All right. So first thing, let's say by domain expert, let's say that somehow I know that the probability of getting a heads is more than a probability of getting tails. On what? On an biased coin. All right, the coin has to be biased in order for this probability of heads to be 2 times than probability of tails. All right, now the second thing I want you to understand is that the probability of tails plus probability of heads is going to be equal to what? Is going to be equal to what? Answers, guys, very quickly in the chat. Is going to be equal to 1, correct? So this is my first equation. All right. Now let me actually put this value. Let me substitute the value of probability of heads here. So let me say PT remains PT, and probability of heads equals to probability of tails. 2 times of probability of tails. And this remains to be 1. This becomes 3 PT. This becomes 1. And I get that the probability of tails is 1 by 3. What would be the probability of heads? Would be the 2 by 3. All right. And this is something you cannot directly solve using the earlier formula. So you'll have to get some kind of an equation like this. All right. And this actually comes from, I would say, comes from experiment. All right. All right. I would say experiments. Oops. Just a second, please. Okay. Now, these are certain things which, no matter how hard I try, will happen. And I am very sorry about it. Okay. What do I do? I don't know how to explain what is happening at my end, but if I'm clicking my laptop, it's actually rather clicking a double click instead of a single click or a right click. Hey guys, looks like the probability of me having a glitch-free class is pretty low these days. I had to restart my computer altogether. I think when I was pressing normally on my trackpad, it was rather doing a right click instead. So it was, I don't know, doing some most randomest things. But otherwise, I hope you're doing well. Yeah, I'm okay with the pen paper. Yeah. Time for a new laptop from Scalar. I have everything new. I think pretty much everything what I'm using is right. It's very new. It's like I think probably 6, 7 months old, not more than that. No, I am not that old school. I think it's my luck is just effed up, I guess. All right, guys. Okay, sure. So let me add the bookmark as well. Experimental probability. Yes, let me share the screen. Is the screen visible? Thanks, Rishabh. Thanks. All right, great. Okay, so where were we? All right, so we were discussing last that this thing comes from an experiment. All right, what kind of experiment? You have to perform a certain experiment large number of times to get to basically see a pattern. All right, so you can probably only tell experimentally that a head is coming out certainly 2 times more frequently when you perform certain experiment large times. All right, and that's where we discuss probability, calculating certain probability of an event experimentally. How do I do that? How do we do that? We perform certain experiment, the same experiment multiple times. How many times? Maybe 100 times, maybe 1,000 times, or maybe infinite number of times. All right, so the probability, the limit is that if you perform a certain experiment infinite number of times, your theoretical probability, I would say P theoretical, all right, becomes equal to P experimental. All right, now why do we calculate P experimentally? Why can't we calculate all the times theoretically? All right, why? Because clearly there can be multiple events or multiple things or multiple factors that might be impacting this probability, and we cannot certainly know all the possibilities. How can we understand all the outcomes? Now today we are just talking about heads and tails. We're talking about rolling a die. Our data science situation is not going to be like that. All right, the real world situation may have so many things to factor in: day, time, the person, all right, other circumstances that we cannot take into account all the possibilities. All right, so the best way is that you perform a certain experiment large number of times and get the probability. All right, now this also, I would say, popularly is called the frequentist approach of understanding probability, but that is what is highly used in data science. We wouldn't like to create complex models to understand a pattern the way we would do it with like heads and tails. We definitely wouldn't like to write long sample spaces, which we have been doing that, let's say in the high school or during the JE times. All right, we will just check the frequency that will come from the data, and we'll calculate the probability. All right, so if I remember, I'm not gonna perform the experiment again, or although I can, if you guys remember, I think we can just quickly escalate and I can add it as a part of an experiment. But what we did is we basically ran a for loop for different number of experiments. We did it for 5, we did it for 10, we did it for 100,000, and we saw it for 10,000. All right, and we saw that the probability of getting, let's say, a die is theoretically 1/2, and with this experiment it was somewhat around, let's say, 0.48. With this it became 4.9, and then it became close to 4.50, but was never equal to 0.50. All right, this became close to 4.9. All right, 4.999, whatever. Right, so how many times do you have to perform that experiment? It depends. Ideally I would like to do it infinite number of times. Is it possible? No. Maybe 1,000 times. Well, maybe if it's not computationally difficult, maybe yes. Maybe 100 times if it is computationally difficult. Well, it depends what is the variance. All right, it depends how much is the variation that you're getting. All right, so if you start getting a graph something like this, that in the starting number of experiments, it's like going up and down, and the probability values that you're getting is changing a lot. But as you keep on doing the experiments, and if it goes somewhat stable, it doesn't change a lot, that is the time you should realize that okay, this many experiments are probably enough to understand or get the value close to my theoretical value. All right, so you understand the concept of theoretical probability. Theoretical probability is nothing but the cases where we can model the situation properly. All right, we understand the outcomes are equally likely, and we can just calculate the probability using our logic, using theory. All right, what is experimental probability, or the other name for this is empirical probability. All right, these probability value, these concepts are same. When we say I have calculated this probability empirically, what does it mean? That I have used the data or have used simulations or experiments to calculate the value of my probability. It may or may not be equal to the theoretical probability, but as we keep on increasing or keep on repeating the experiments to calculate that value, we will somewhat get closer to the theoretical probability. All right. Now, just to finish off this, I would say, module, I would like to also discuss, for the sake of formality, two laws of probability. First law, I would say, laws of probability. All right. What is the first law? The first law says that the probability. Okay. The probability value will be any event would be between 1 and 0. All right. When can it be 0? Let's say you're trying to understand the probability of appearance of 7 while rolling a die. All right. Can you get a 7 while rolling a die? No. The probability will be equal to what? 0. How can the probability be 1 equal to 1? We discussed the probability of a sample space is equal to 1. What do we mean by probability of finding sample space? You might be interested on getting probability, let's say, knowing the probability of getting either 1, 2, 3, 4, 5, or 6. All right. What is the probability of getting 1 or 2 or 3 or 4 or 5 or 6? 1, right? Of course, we'll get one of them, right? Second law says that the probability of all the events, all right, all the events will equal to 1. All right. If you sum all the possible events, all right, it will definitely, it will sum up to 1. All right. Any doubts in here? This is just for the sake of formality. But sample space, or we can just say that the probability of the sample space is equal to 1. All right. Here we'll talk about mutually exclusive events, but we'll discuss in details later. All right. You can say that the probability of the sample space is equal to 1. Any doubts in here? Any doubts? I will add the screenshot of the simulation we did in the last class. I'm just skipping it over because it's easy and we have a lot to cover and I want to focus on things what matters. All right, really. But any doubts? Let's take 1 minute break, and meanwhile, let me add the bookmark. I would say compound events, marginal no doubts. Wow, I'm so surprised. Ask. I think there used to be so many doubts. So far, so good. This is more like a revision so far. Correct. Cool. No, I thought nothing was right about the last class, so I think I'll have to explain everything. All right. No, just kidding. All right. So let's talk about compound events. All right. What do we mean by compound events? All right. So at one time, we might be interested in more than one single event. All right. Usually we discuss 2 events, but there's nothing stopping you to not talk about multiple events. And as when you progress in machine learning, as when you learn Bayesian machine learning, you will see that there can be multiple events involved in any discussion. But let's carry this discussion with 2 events. All right. Now, how can 2 events occur? All right. They can either occur simultaneously, all right, or they can occur one by one. All right, these are two different kind of events that we'll come across, and we'll discuss examples of such, although there is no I would say proper categorization. Well, we'll look at two, three different kind of examples to understand wherein in some cases we'll have simultaneous events, and in some cases we'll have events occurring one after another. All right, here I think there are two categories. If I broadly say, there is something called with replacement, all right, and maybe I would say without replacement. All right, so you perform one experiment with replacement, making the sample space same again, and other cases you don't do any replacement, so your sample space changes. All right, we'll look at these examples. All right, so to carry out this discussion, let's talk about the third game. All right, what is our third game? We'll go and we'll play with cards. All right, let's play with cards. All right, so first thing, how many cards do we have? We have 52 cards in a deck, and I am not here talking about the 4 joker cards which are present. All right, so I'm not including them. All right, within 52 cards we have, I would say, 4 suits. What are the different 4 suits? We have diamond, we have a spade, then we have a heart, no, this is club, and we have a spade. All right, we have 4 different suits. How many cards for each? We have 13 cards for this, we have 13 cards for this, we have 13 cards for this, and we have 13 cards for this. All right, what can be different type of cards here? We have an ace, 2, 3, 4, until what? Until 10. All right, ace is basically what? 1. All right, it's equivalent to 1. All right, then we have I would call them as numbered cards. All right, numbered cards. By the way, these are what? These are suits. So we have 4 different suits. All right, and we have 10 different numbered card per suit. All right, the next thing we have is we have a jack, we have a queen, and we have a king. So there are 3 face cards in any suit. All right, I'm just going slowly just to make sure everyone understands all of it. I don't think there should be any doubts, so let's move forward. All right, now your friend basically went to casino, and you're gonna play this game where you have to pick a category. What? You have to pick a category. All right, you are not going to bet on a particular card. Just the way you earlier, what you used to do is like you used to bet on a particular number. All right, 1, 2, 3, 4, or 5, or you used to bet, let's say, on heads or tails. All right, here instead of betting on a card, you will bet on a different on a particular category. All right, what can be categories you can bet on? All right, so you can bet on a face card. All right, how many face cards are there? There are 3 face cards per suit, and I would say 3 cards per suit. All right, and we have 3 4s are 12 cards in total. All right, face cards. Next category that we have is color card. All right, and within color card you can have 2 categories further. You can pick for a red card, or you can bet for a black card. All right, how many black cards and red cards are present? So we have 26 red cards and we have 26 black cards. All right, next you can probably bet for a numbered card. How many numbered cards are present? We have 10 numbered cards, 10 cards per suit. All right, and then we'll have basically 40 cards in total, which are numbered cards. Correct? Oops. Still trying to learn the technology, but I hope I am 1% better every day. Numbered cards, we can bet for odd cards. How many odd cards would be present? How many even cards would be present? All right, so odd and even categorization is only possible for these numbered cards, and out of these 40 cards, 20 are even and 20 would be odd. All right, and that is sensible. All right, so I would say for this, oops, five cards per suit and 20 cards in total, and this would be same, so I'm not going to write it again. All right, any doubts in the question? And then we can do some practice questions, we can solve something. No, I'm not gonna include as I said, we are not considering four joker which are present as a part of 52 cards. We are only talking about the suit cards, and within the suit card, I'm gonna call A or 1 to 10 as numbered card, and J, Q, and K as the face cards. All right. J is the 11th card. Jack is the 11th card. I know, but we're going to call them as 50 face cards. All right. No need to like remember. No need to like play cards. All you have to remember is this. All right. And we can go back and learn it again. But give me a thumbs up if you are good to go. Give me a thumbs up if you are good to go, and if you could understand this. It's okay to not remember, but can you understand? Perfect. All right. Let me take a 10 seconds break. All right. So let's talk about joint probability first. All right. So you and your friends are basically betting. All right. So you want to understand what are the cases when both of you would win. All right. So let's say that you say that I will say maybe I'll say Anant, or my friend, let me say Mudit. All right. Okay. So I am betting on a red color card. All right. I'm saying that the host is going to pick out a card from the deck. So this is the deck of 52 cards. All right. 52 cards. The host is going to take out one card. All right. Only one card from this deck. And I am betting that it's going to be red color. All right. My friend Mudit is saying that it's going to be an even card. All right. It's an even number of card. Right. Now, there are multiple possibilities. Whatever may come might actually not be a red color card, might actually not be an even card, might be a red color card but not an even card, might not be a red color card but an even card. Anything is possible, any combination is possible. All right, what we are interested is in knowing is when, let me denote this with A and let me denote this with B. All right, what we are interested in is knowing what is the probability of A intersection B. What do we mean by A intersection B? We mean what are the cases, what are the events when both red colored card and even card is possible. What are the cases when both Anant and Mudit, oops, my iPad got disconnected. Yeah. What are the possibilities when both Anant and Mudit win? All right, both of them win. All right, so let's quickly write down a couple of things which I would say might look an overkill, but you should always follow it. All right, so first let's pen down what is an experiment here. All right, so experiment here is picking a card. All right, you are only picking one card. All right, this might sound an overkill for advanced learners or for those who have been doing probability. I would suggest that it's okay to think from first principles and think everything. All right, just when you're learning. All right, what is the sample space? All right, what is the sample space here? What is the sample space? Answers in the chat very quickly. All right, so we have 52, I would say 52 cards in the deck. that makes the sample space. All right, 52 cards in the deck. All right. What is an event? All right. So there are two events here. All right, that we are interested in. Event A. Event A is event A is a red colored card. Event B is what? An even number of card. All right. Is this clear? Any doubts in this? By the way, this probability itself, this is called with multiple names. It's called P, A, and B. All right. Probability of having event both A and B together. All right. Simultaneously. It's also called P, A intersection B. And we'll see the Venn diagram and see why we call this. So, all right. And this is sometimes also called as P, A, comma B. All right. And that's why this is also called joint probability. All right. What is the probability of occurrence of both the events jointly? All right. Joint probability. All right. Joint probability is nothing but intersection of two or like whatever multiple number of events. All right. Now, before I actually get into details of how to calculate it, I also want to say that joint probability, JP, is symmetric. Is symmetric. What do we mean by that? Probability of A comma B will actually be probability of B comma A. Why? Does it matter if I write A or B first? All right. I'm saying what is the probability that both of these events happen together simultaneously? Does it matter if I write A or B, whichever I write earlier? No. All right. So we can say probability of A intersection B equals to probability of B intersection A. All right. No questions in here, right? Okay, so if there are no questions in here, we'll try working out on the understanding the sample space to answer this question. What we are interested in is probability of a red card and even card. All right, so let's make the sample space. To make the sample space, I'm going to make a Venn diagram. All right, so every time you make a Venn diagram, it's always suggested that you write the number of how many outcomes are present in here. So if this represents the deck of a card, all right, this has 52 cards in present. All right, how many red cards do we have? How many red cards do we have? We have 26 cards which are red. All right, let me just make it a little fancier. All right, how many even cards do we have? All right, we have what? How many even cards do we have, by the way? How many even cards do we have? Remember earlier we discussed that we have five even cards per suit, and we have 20 cards in total which are even. All right, which are 20 cards in total. So we have how many? We have 20 cards in total which are even. All right. How many of them both are red and red and even? All right. So this would be represented using this part. All right, where there is an intersection. All right, so we discussed that there'll be 10 red cards, red even cards, and there'll be 10 black even cards. All right, so this number would be what? 10. All right, how do I find the probability? What are my desired number of outcomes? I have 10 desired outcomes. All right, how many total number of outcomes possible? I have 52 possible outcomes. The probability of having a red card and an even card, a joint probability, would be 10 by 52. Any questions in here? Any questions? If there are no questions, I'm going to give you 1 minute, and I'm going to probably let me see if I can paste a screenshot within these notes. If I can do that, that would save me some time. Oops. Okay. Okay, so the to do for the next class would be learning how to probably insert a screenshot. All right, so probably you may take like a 2-3 minutes break before I like write down a big table to probably uh, make you understand. All right, so first thing, we have two variables here. One is number on the card. All right, so oops. All right, so we have number. All right, all right, and what can possibly the numbers? I would say 1, 2, 3, 4, 5, 6, 7, or I would rather call it types instead of numbers because I might want to add face cards as well. So I would say maybe type of card. All right, so 9, 10, then we have jack, we have queen, and we have king. All right, and then we have other thing, another variable. What is the other variable? We have the color. All right, what would be the color? All right, so the color can be, possible color can be red or black. All right, what can be the occurrence? What can be the occurrence of this one red card? What would be the occurrence of one red card? How many red cards of number 1 would be possible? 2. All right, how many black cards would be possible? 2. All right, and similarly all of them would be 2. Is this clear? Any doubts in here? Is this clear? Perfect. I think there were some questions related to A minus B, B minus A and B. Okay. I am not sure, Tulros. I shall probably just unmute you very quickly and I should ask you what is the doubt so that we don't pile up anything. Tulros, hi, can you hear me? Hello. You are in a disturbed environment. All right, so Tilros, in that case, probably we shall just take it up later. You may just unmute yourself. All right, thanks. So if this is clear, I think let's do a couple of questions related to it. So first thing, I would like to know what is the probability of getting a red card. All right. From this chart, what do you think? How can you calculate the probability of red card? I want you to tell me the process, not the answer, but probably the process. All right. So how will I find the red card? I will check how many total number of red cards are present here. All right. So the total number of red cards are present here are 26. All right. So there are 2 occurrences of each and there are 13 different kinds of cards possible. All right. So there are 26 possible red cards. All right. There are 26 possible red cards. What is the sample space? Probably the total of all of them. That would be 52. All right. I'm not going to simplify, but that's going to be the answer. All right. Now this, although seems like an easy question or like an easy stuff, I think it has an importance and it's called marginal probability. All right. What do we mean by marginal probability? When we're interested, when there are 2 variables, all right, there are 2 variables, type and color. All right, so type has multiple possible outcomes, color has multiple possible outcomes, but we are not factoring in the second variable. We are only interested in knowing a specific variable. All right, a specific value of a specific variable. We are not talking about card here. All right, so this would be a marginal probability. All right, so let's take another example of calculating marginal probability. What is the probability of getting a 2? All right, how would you calculate the probability of getting a 2? How would you calculate the probability of getting a 2? All right. So in this case, let me say, basically I summed this column. All right. So the probability of 2 you will get by summing this row. All right. You see what are the possibilities, what are the outcomes, desired outcomes, how many desired outcomes are present. We have 4 favorable or desired outcomes. How many total outcomes we have? 52. All right. 4 by 52 is what we get. And again, this is an example of marginal probability. Why? Because out of 2 variables, we are only interested in one of the variables. All right. We were interested in the color here, and we are interested in the type here. Earlier, if you look, we were interested in knowing both the things. All right. So that is why it was called joint probability. All right. So understood the difference between marginal probability and joint probability before we talk about the devil, before we talk about the conditional probability. Clear? Perfect. So let me look if we have something else to cover before talking about conditional probability. Okay, so set. Okay. So let's actually, before talking about conditional probability, let me also take up one more example. All right. So the here question is that you are interested knowing what will be the chance of either me or Mudit winning. So I have betted on a red card. Mudit has bet on what was it? Even number, right? If I'm not wrong. All right. Earlier with P A comma B or P intersection B, we were interested in knowing what is the chance of we both winning. All right. Now I am interested in knowing what is the chance of either one of us winning. All right. So we are a team now. All right. So if Mudit wins, I am also a winner. If I win, I am also a winner anyway. All right. So we care about the cases we call a win if either one of us wins. All right. So let's try to probably again create a sample space here. All right. And try understanding. And we'll probably then come to the formula. All right. So we had our sample space of 52 cards. Then we showed our red cards. How many red cards do we have? We have 26 red cards. All right. Then let me show set of even cards. All right. How many even cards do we have? We have, let me say 26 in here. How many even cards do we have? We have 20 even cards. All right. How many common cards are there? Let me say. So we have 10 common cards. So let me actually update this value to 26 minus 10. What is 26 minus 10? I have 60. All right. Let me update this value to 20 minus 10, which is 10. All right. Here also I can just maybe do it like this: 26 cut 60. All right. Now here, what do you think? What would be the value? What do you think? What would be the value of knowing any one of us winning? All right. So first, let's get to the answer and let's derive the formula later. All right. So first thing, I think, irrespective of whatever happens, if any of the event happen, or any of this event happens, it's a win. All right. So I can just calculate by looking at the Venn diagram. I can do a 16 plus 10 plus maybe what again a 10, and right, and then total number of possible outcomes are 52. We get 36 out of 52. Correct? No doubt in here. All right. How would you do if, let's say, you have probability of A? All right. If you have probability of B, all right, and you have probability of A and B, because this is what you've learned. All right. So this is This is what? A marginal probability. All right. This is also marginal probability, and we have learned enough things how to calculate A. How to calculate what is the probability of A? We can do what? 26 by 52, right? Red color. Even number, 20 by 52, right? A and B, we just learned. All right. What is it? The joint probability. Now, I'm not going to get into details. What is it? But yeah, I think it was 10, if I remember correctly. All right. How can we calculate? How can we calculate this using a formula? So if we have this, the formula of calculating union is, you take up PA, this one. All right. What was it? 26. You take up PB. What was it? It was 20. All right. And then you subtract something. All right. You have to subtract. Why do you have to subtract first? You took this and you took this. Do you notice that you ended up taking this thing multiple times, double times? All right. So you're going to subtract this once. All right. And this gives you the final formula of calculating the union when you know the intersection. All right. So this is the first formula that we've got. How do we calculate intersection? You will have to probably, as for now, what you are being told is that you have to create some kind of a Venn diagram or some kind of sample space tree or something, or like, some two-way table. As I say, this is a two-way table, right? You'll have to find this to basically look for common things. All right. Or you may have like, maybe set present. All right. I think I wish I knew if there's a way to like lock the screen so that I don't end up zooming in, zooming out. Oops. All right. So you might have, let's say, sets. So what is set of for A? Set for A, it's a red color. So you have diamonds here, multiple diamonds. You have multiple maybe hearts. All right. And within this set, you may have even numbers. So you may have an even diamond. All right. Sorry, a diamond of 2, a diamond of 4, a diamond of 6. All right. And here you can probably find all the intersection. You can take a set of these two. Yeah, I think that's how you can calculate the intersection. Just tell it. There is no formula for calculating the intersection. If somebody tells you that you can calculate this by doing this, by multiplying, this is wrong. All right. This is wrong in general. This is for a generic case. We'll discuss that generic case, but this is wrong. You cannot by not knowing any information, you cannot just multiply simply two things. All right. You need to have more information to do this. All right. I would say not applicable everywhere. So you can use the shortcut to reset. Yeah, I think command O. Yeah. Thanks, Rahul Shivani. I think, yeah, I think these collaborative efforts would help me also improve my writing and probably my writing skills as well. All right. Any doubts in here? I think I just wanted to sort of cover these things just for the sake of formality, because there are a lot of people who might be not remembering or must have forgotten. But I think we are good to go to discuss other things. All right. So let's talk about another case. I'm going to say, let's talk about another case. So now let's say, bet. Let's say Anant bets on Jack. All right. Jack is J. All right. So I bet on a Jack. Mudit bets again on an even number. All right. I can quickly maybe create a sample space. All right. So first thing, let me create a sample space for a Jack. Let me say 52 here first, very quickly. Let me create a sample space for Jack. All right. And how many cards of Jack would be there? There'll be 4 cards. All right. Now you have to tell me how to create a circle for showing even numbers. All right. Shall I do this? Shall I do something like this? No overlap. Correct. So okay, I hope if I do Control Z, it can just, okay, yeah, it's okay. All right. So I think every one of you is clear that the even number, these 20 numbers won't overlap with this. All right. Now this is example of something called mutually exclusive event. All right. Forget my writing. It's mutually exclusive event. All right. The other name for this is called disjoint sets. All right. So disjoint sets is something we use when we talk about set theory. I think when we are talking about probability, the mutually exclusive event, or ME, is what is the preferred name. All right. Separate circle, any doubt? Can we say they're independent? No, not yet. We'll discuss. We'll come to independent events, and I'm gonna do a compare and contrast. No worry. We'll discuss that. Answer is they're actually not independent. They are dependent. The answer is this. We'll discuss in details. Any questions? All right, so if there are no questions, I think we are clear what is a disjoint set, and we'll cover more things. I have got to know that you are used to the idea of taking a 10 minutes break at 10:30 from your DSA lectures, but I'm not also sure if I have bandwidth to give you a 10 minutes break. Independent is not equal to mutual exclusive event. No, no, we'll discuss. We'll discuss. Is it okay if we take a 5 minutes break? Perfect, perfect. All right, so I'll see what's the time right now. Um, what's the time? I don't want to move anything. Can just someone tell me? Okay, it's 10:39. I'll see you at 10:45. We'll see each other at 10:45. We'll start sharply at 10:45. All right, I think we are good to go. I let me just quickly check the messages. Okay, I think most of the people are okay with extending the class. I'll have to extend the class. I'm sorry, maybe till 12 as well, but I want to make sure that I don't rush. Uh, no, it was the time that you got confidence. What confidence? Oh, okay, 9 to 9:30. Okay, got it. Well, being confident and having trust is really important. I think for me personally, I feel trust is the most important factor. Uh, if you don't trust anyone, at least trust Abhimanyu and Anshuman. They would absolutely make sure that your experience is great and greatest. So just trust them. And even if after multiple trials, if you're not able to trust something, be it the assessments, be it the program, or even for that matter, the instructor, I think that calls off for a change. Trust is really important. Trusting the person, trusting the program is really important. Otherwise, you'll end up wasting your time in just thinking and overanalyzing things. Okay, all right. So let's imagine another control O, as somebody suggested. Control O. Nope, didn't work. All right. So where I was. Okay. So let's imagine another case. All right, wherein uh, event one is drawing a red card. All right. Event two is drawing another red card. All right. So these are two cases, two events. Event of drawing one card in the first game. I would say this is the first game, first trial, and this is a second trial. All right. Now, there are two variants. I'm going to talk about variant one here. Variant one is the host draws a card for you, from the deck. All right. So this is a deck of 52 cards, draws a card for you and puts it back to the deck. All right. Puts it back to the deck. All right. And then again draws the second card. Now what happens here? This condition is called with replacement. What do we mean by with replacement? We performed an activity and then we made our sample space same. All right. If I would have kept it aside, that would have been, I would say, I'll make that variant again, but that would have been called a without replacement case. All right. Now, I want you to ask one thing. First, the probability of drawing a red card is what? A 26 by 52. What is the probability of drawing the second card? What do you think? What is the probability of drawing the second card? 26 by 52. Why? Why do you think that probability of drawing the second card won't be dependent on what happened in the first case? Why? We made the sample space same. So these cases, I would say, the first game and the second game are independent events. All right. So drawing red cards from the deck in the first game is independent of drawing a card from in the second game. All right. And the theory says that if two events are independent, then you can just multiply by their probability. All right. Why? I can take maybe an easier example here just to explain. Let's say you are tossing a coin two times. All right. So what would be the sample space? I am coming to mutually exclusive. Wait, let me finish. All right. So we have heads and heads. All right. We can either get tails or tails. We can get heads or a tail, or we can get tails or head. All right. So this is the sample space for tossing a coin two times. All right. Now here, if I make these trials, all right. So possibility of one something to be here is what? Is what four? Sorry, is what two? There are two possibilities how we can choose. Oops. Sorry about this, guys. All right, so we can choose what will come at the first place in our first trial in two ways, in two possible ways. Yeah. Okay. Give me 1 second, please. I think this is happening again. God. Okay, I am genuinely sorry for this, but I literally practice on this notability for like an hour, and I'm honest. I'm being honest, and I don't know what is happening now. No, I didn't press. Actually, my mouse is just weird. Weird. Like when I'm clicking, it's actually opening a right. It's doing a right click. It's not with the notability, I think. I mean, I don't know what even I can do to like not have these kind of things. No, it's not the application. It's actually my Mac creating some problem. I can't even stop sharing. Like I'm trying to click this button, but it's not happening. No, I'm not using a mouse actually. I'm just using my trackpad. I think I'll probably have to. Yeah, Macs are supposed to. When this is an M1, never created this problem actually ever. I think I'll just probably have to restart my system. I'm sorry. I'll ensure something can be done with this regards. This Hi guys, sorry, I actually don't know why it is happening. My Mac has never seen like this. It's just, I guess the times are not good for me. Anyway, I think let's get back, and I hope still things are better than OneNote, which is what Blackmagic. Yeah, I think I need to probably ask someone to like do something with Nazar and something or something. Screen is not visible. Okay, let me share. Okay, is the screen visible now? Cool, perfect, perfect, perfect. So where were we? We were discussing that B, the probability of occurrence of B is actually independent of probability of A. All right. Do you understand independent events first? We'll discuss the differences, but do you understand the events first? All right. So here we can actually say that if we are looking for probability of A and B, and if the events are independent, right? A event was getting a red color in the first game. B was getting the red color in the second game, and both of them are independent. So I can just multiply their probabilities directly as it is. How? Because I was taking this example of heads and tails. So I was saying at first places, what can come? We can either do an H or we can do a T. All right. What can come here? I can either take an H or I can take an T. Right. So there are four possibilities, right? So how would you get four? You will do 2 into 2 is equal to 4 possibilities. All right. So basic combinatorics, I think I'm not gonna get into details, but I think it must be fairly simple. As long as we are able to explain that these events will be independent, won't determine each other's probability, won't factor in, I think we can just simply multiply. Where can we not do it? Let's talk about variant 2. All right. So variant 2 is that you basically got a red color in from the first deck. All right. So red color from the first deck, 26 by 52. All right. Then you don't replace it. All right. So I'll say the case is without replacement. All right. The case is of without replacement. All right. Here I'm not replacing it. What do you think will be the probability of getting a second uh, red color? What do you think? Uh, how should I factor in? How should I factor in here? Right. So the sample space first changes and it becomes 51. What is the probability of getting a red color? So this is where we got a red color. Here we have one red color left, one less red color. So the whole probability will be 26 by 52 into 25 by 51. All right. Now I am going to explain just in a little while what is conditional probability, but this is actually a conditional probability. So if I have to write this, this is actually P of A and P of B given A. All right. This probability called 25 by 51 that we've got is actually not P of B, but P of B into A. All right. So in general, the formula is, I'll explain it. Don't worry. I'll go to conditional probability. I'll explain. If I have to calculate P of A and B, in general, it's P of A multiplied by P of B given A. Given A as in like, we know that A has occurred. We'll do conditional probability. Don't worry. All right. And if A and B are independent, what do we mean by A and B are dependent? Then probability of B given A, given that A has happened, probability of B should not be dependent on whatever has happened earlier, right? So this will be equal to probability of B, right? And I can just substitute this and say P of A into P of B, all right? And P of A and B equals to P of A and B, which is what we have been doing until now for independent events. with replacement was an example. All right. There can be other kinds of independent events as well. We'll discuss those. But in general, I would say this is the general formula, or this is the case where events are independent. All right. Give me a thumbs up if this is clear. Give me a thumbs up if you understand this, that this 25 by 51 was not P of B. It was actually P of B given A. All right. What is given? A has given, A has happened. So we will have to reduce one card from the total sample space, and we'll have to reduce from the numerator as well, because already we've picked one red card. So it will be 25 here. All right. So one question from Dilreet, and then we'll move to conditional probability properly. One question: if after selecting a jack, I put it back and then select even card, then it is an independent event. Yes. Yes. Why it is an independent event? Because your sample space remains same for your second try. All right. As long as the sample space remains same, it remains intact. That becomes independent. All right. Cool. Okay. So we've discussed independent events. Let's go back and let me ask you a question. Tell me, if let's say two events are disjoint, so these are two disjoint events, right? Tell me what would be the probability of A and B. What is the probability of occurrence of A and B together? What is the probability of A occurring A and B together? 0. All right. So this is also, I would say, I'll slowly learn to like sort of understand where to use what color, but yeah, I think I'm right. So the probability of occurrence of A and B would be 5 or would be equal to 0. Why? Because these two events cannot occur together. Correct? I don't think there should be any doubt. Now, I think there was a first question if mutually exclusive events are same as independent events. So let me give you two answers to this. All right. Let me explain it two ways. All right. First, for the formula approach here, for disjoint event or mutually exclusive event, we say P of A and B equals to 0. All right. Whereas for independent events, we say P of A and B equals to P of A multiplied by P of B. Now this can only be 0. This can only be 0 when either A is 0 or this is 0. All right. All right. So naturally, I would say naturally independent events have probability greater than 1 of occurrence, until unless the probability of one of the events is 0. All right, which is a generic case. All right, it will be a trivial case if one of the event has 0 probability, right? Then we might just not be rather interested knowing about that event altogether, right? Because if you're sure that a certain event is not happening, then why to even talk about it, right? So by default to your answer, I would say first reasoning, independent events are and mutually exclusive events are different. Why? By this definition itself, mutually exclusive events will have 0 probability of occurrence together, and independent events will have a probability greater than 0. All right. Not so naive, but first reasoning. All right. Let me come to the logical, or say I would say intuitive reasoning. All right. So let me talk about two disjoint sets. All right. Let me call this A. Let me call this B. Okay. Now I know that on drawing A, on drawing, let's say something, A came up. All right. On drawing, let's say A came up. All right. A occurred. Does it tells me anything about B? Does this sentence tells me anything about B? Think about it again. I think I should add some good quizzes next time. I'll prepare. Right. So it actually also tells me that B cannot come up. Why? The question is does this sentence that A turned up or A came up tells me anything about B? Yes, it actually tells me that B cannot come up. Why? Because these are disjoint. All right. Do you think A and B are independent? Do you think A and B are independent? No. Answer is why? Because knowing about A, I am getting to know about B. So they cannot be independent. Try to think about them logically. Uh, if I know about A and I know that B cannot occur, then the occurrence of A is actually impacting the occurrence of B, right? So they are not independent, right? So as a thumb rule, again, I would say this thing works for me all the time. All right, and that is how I think about it. Even in the last game, the example was bad. You can go back to the video. Although I lost confidence, but I didn't say anything wrong. I whatever I said was absolutely right. Why I don't uh, get confused? I have two thumb rules to understand. I will always remember this image that helps me remembering how mutually exclusive events would look like. All right. And I would also remember that knowing about A is actually also telling me that B cannot happen. So they are not independent. All right. So just to conclude this, mutually exclusive events are not equal to independent events. Give me a thumbs up if this was clear. Why do we multiply two things and not add? I think simple logic. I would say if we have 1 2 3 here, if we have 4 or 5, and if you have to find pairs, all right, what can be possible pairs? You can pair 1 with 4, you can pair 1 with 5, then you can maybe pair 2 with 4 and 2 with 5, and then maybe you can pair 3 with 4 and 3 and 5. How many cases are possible? 3 into 2, correct? 6 cases. All right. Do you understand why we use multiply here? How is ME different from IE? We just saw Navroop that mutually exclusive events are actually not independent events. They are rather dependent events. Why? Because knowing about A tells me about B. Yes, like a jack and even card draw is ME. They are not possible together. So they are dependent events. So knowing that, let's say Jack hasn't come up, it can actually tell me something about the even card. All right. What can it can tell is not sure, but what we can definitely say is that definitely it is saying something. So they are not independent. Probably knowing that it's not a Jack actually increases the probability of occurrence of the even card, if you think, right? Because I am more sure that it's probably an even card, right? Until knowing that it's not a joint, right? Right. Both head and tail cannot appear at once. Any. Correct. 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 Arijit, let me just take up one last question, and I'd like to probably finish the concept first. Otherwise, we'll spill over this class even after 12. In case of ME, we are drawing only one card, and that's why A and B are not possible together. But in case of independent, we drew two cards by replacement and then used event A on draw. Is it possible to have an ME scenario with two draws? Um, mm, so Arijit, just to answer you, maybe not the best example, but just to answer you, I would say, do you think TT and TH can occur together? Do you think this event and this event can occur together? Again, like, probably to answer your question, maybe yes, the right example and answers your question well, maybe intuitively not the best example. No, for toss one, yes. For two tosses, yes, for two tosses. How yes for two tosses? How is it possible to get a tails and tails head together, right? You're just doing two tosses, correct? So either you can go do a tail, you can get a tails or tails, you can get either a tails or heads, or you can get a heads or tails, or you can get a heads or a heads, right? And all these cases are mutually exhaustive, right? I mean mutually exclusive, right? Right. Again, probably towards the end I will try to think of something more intuitive, but I think this answers the question at least, Arij. When I'll have more time, once the topic is finished, I'll probably try to think of another example, like a better intuitive example. All right, so if this is clear, let's move to discussing something called conditional probability. By the way, just to quickly show you, to just finish this off, this diagram can actually be of independent events. All right, this diagram can be of independent events. And think about it, go back, revise all of this. You would actually understand that if this is not possible, then this is the only possibility. All right, and this actually can represent two independent events. A and B can be independent, and still this would look like this. Don't remember this to confuse. My thumb rule would be to remember this, and all to remember these two things, to remember this diagram and to remember this. All right, now if this is done, let's move to something called conditional probability. All right, so again, I think as I could figure out from the last class, people were having confusion between conditional probability and joint probability. I did not get confused. You can watch the video, but yes, I lost the confidence as well. I agree. All right, so let's try imagining a condition that, okay, so you might want to first, now Anant wants to probably now bet on even number. All right. So for first, what is the probability of getting an even number? It is 20 by 52, correct? All right. Let's somehow, like, somehow, while actually the host picks a card for me from the deck, after that, after picking, the host sees this card and comes back and tells to me, hey Anant, what I can tell you is that it's a red color. All right. The host doesn't tell me whether it's an even number or not. All right. I will win only if it's an even number. But host tells me that, hey Anand, what I can tell you is that it's an even number. Sorry, it's a red color number. All right. So let's first, like, as a part of doing a proper exercise, let me write down certain things. So what is the experiment here? Remember, the experiment remains same. Experiment is picking a card from deck. This is the experiment. All right. Let's talk about sample space. What is the sample space? Again, all 52 cards. All right. Now, what is the event here? Now, actually, there are two events happening here. Two events of our interest. Let me say event A. What is the event A? Event A is the one that I am interested in. The card is even number. All right, this is the event A. Remember that I'm denoting this with A. Next event, the host tells me that the card is red colored. All right. Now, clearly, right at this moment, we can see that they are definitely not independent. All right. And even number and dead number looks somewhat related. But let's try to understand what we are trying to even say. All right. So we denote this situation by writing something like P given B. All right. This is called given. All right. What does it mean? How it tells me how would the probability change? What is, let's say, the updated value knowing that B has happened? So knowing that B has happened, how will my belief change about, or I would say, what would be my updated belief about what? About occurrence of A. All right. I am saying earlier, I used to think that my chances of winning are what? 20 by 52. How will my belief about winning change when the host tells me that it's a red card? All right. How will this change? All right. So clear with the question, clear with what is required from knowing from conditional probability. No, it's not a joint probability, Muthu. Joint probability is saying, tell me what is the probability of having A and B together. All right. What is the probability of occurrence of A and B together? Joint probability says, I am already telling you that B has happened. Now, tell me the updated probability, or tell me the updated chances that you feel what probability of A will have. All right. So this actually translates to what is the probability of A knowing B has happened. I am saying that B has happened for sure. Here I am saying, tell me the probability of occurrence of A and B together. Why not B given A? Yes, we can. We can find B given A. I just for this use case, I want to calculate A given by B. I want to know what would be the probability of A when B has happened. And there is nothing stopping me to calculate B by A given by A. Okay, I think Shubham Tomar, you gave me the right answer. And without going into the formula approach so that you can understand this intuitively, I'm going to make certain Venn diagram to explain what is happening here. All right. And I'm going to also make a tree diagram to understand, to make you understand what is happening here. So whatever works for you, you can probably take it up. All right. So let's do some drawing. So we had an earlier sample space. All right. This is what? 52 cards. All right. And we had our red cards. All right. And then we had our black cards. All right. How many red cards? 26. How many black cards? 26. Okay. So how many numbers in here? I would say numbers. How many numbers here? We have 20 numbers. All right. How many odd? I would say 10 odd and 10 even. 10 odd, 10 even. All right. And then I have how many face cards? 6 face cards. Actually, let me just not write it up here. Otherwise, it will be a mess. So this is red and this is 26 cards. This is black and this is 26 card. All right. So let's just write what all will this guy have. It will have numbers 26. All right. Odd. Sorry, numbers would be 20 here. Odd will be what? 10. Even will be what? 10. And face cards would be 6. I don't think there'll be any doubt in here. Just think about it. And this black guy will have the same thing. All right. Now, what does the host tell me? Host tells me that it's a red card. All right, so let me draw my updated sample space. All right, so my sample space actually is now this. Oops. Is this. All right. So how many things we have? Again, we have number 20, we have odd 10, we have even 10, and we have phase 10. All right. So let's calculate the probability of me winning in the first situation. This is the first situation. And let me also calculate the probability of me winning in the second situation. All right. So first case. All right. So the first variant, I want to know what is the probability of A. What was the event A? The event A was card is an even number. All right. So what can be the chances of having even number here? So I can have 10 even number of red type, and I can also have 10 even number of black type. All right. So I'll say 20. How is it? I will just say 10 plus 10 by 52. All right. So this is the probability of me winning earlier. All right. What is my new probability of winning? All right. So how many favorable cases? 10. All right. How many total cases? How many do I have? 26. All right. So this probability is 20 by 52, and this probability is 10 by 26. So if I do the calculation, if I actually do the calculation, can somebody do the calculation for me actually very quickly? 20 by 52 is what? Okay, sorry, this is gonna be 6 face card. Sorry. Thanks, Arijit. Although it doesn't make a difference. I mean, it does not make a difference in with our example. 384. Okay. What is the probability of this? 10 by 26. Very quickly, can just someone tell me? Point 384. All right. So knowing that, I would say this is actually P given B. All right. And this actually, I would say, is coming out to be equal to P of A. All right. Which means it's actually not dependent on B. Right. Why? It's coming out to be C. All right. So this is example of an independent event. We've proven it that it's an example of an independent event. Is this clear? I think there was some confusion earlier and people were saying we can just, do something. I'll come to the formula. Don't worry. I'll come to the formula. But this appears to be an example of independent event. Should this be actually an independent event? I'm just thinking. Yeah. Any doubts in here? How is this an example? What is the doubt? I'm not sure. Rishabh, can I unmute you? Or Shubham, can I unmute you? Maybe one of you can just help me understand.
Hi, Anand.
Hello.
I understand like how you are saying that this is an example of independent event. Like I understand when two events have no effect on each other, like their result is not affecting each other, then you can say them like they are independent.
Mm-hmm. Mm-hmm.
But like
So,
you.
I'm actually just thinking, are you sure this is giving you the same result? So
Yeah.
independent event, I just marked it as an independent event. Why? Because this actually means probability of A given B. All right. So how will my probability change? What will be my updated belief of A, knowing that B has happened? All right. So earlier probability was what? Something 0.384. All right.
Okay. Yes.
Now this probability is apparently coming out to be 384, which someone, if I'm, can someone check? I am not sure if this
Actually, 20 by 52 is 10 by 26 now. So it is actually correct. The equation is
10
actually
by
correct.
22. Yeah, all right. Yeah, sure. So logically, I think let me just check if I'm doing any mistake here. But the whole point is by changing by okay, my network is showing poor detect. I hope my screen is visible and properly
Yes, yes.
not being.
It's visible. It's totally
All
visible.
right, all right. My video probably just would disable. All right. So here, since the updated value of A, the belief of our belief of A, even after knowing that B remains same, that means that A didn't get changed by knowing anything about B. Correct?
Yes, yes, of course.
Yeah. So do you think this means that B, knowing that B has happened, or knowing whatever has happened to B, changes anything about A, changes anything about the probability of A?
No, but this is because you are asking two different questions, right? You have a set A where you are saying there are red cards and there are 26 black cards, and there is second question is different. So if you
What
are
is the
asking
second
two
question?
different questions and then you are saying that if you combine them and say they are independent, because of course because they are two different questions.
How are these two different questions? I'm just trying to understand what do you mean by two different questions?
Like if what is the second question? Like you have numbers only, or you have like 10 odd cards and 10 even and 6 face cards.
Mm-hmm. Mm-hmm.
And the first one is like all the cards, the 26 red cards and 26 black cards. So you just take two questions, and then so definitely they have and definitely they are working separately. So obviously.
So what we are trying to say here is that we earlier we had a sample space of 52, correct?
Yes, yes.
Now, when I had a sample space of 52, the probability of getting a red card was what? 0.384 or 10 by
Mm,
26, correct?
yes, yes,
No,
yes,
it
definitely.
should be probability of, sorry,
Red card,
even
not
number.
even card is.
Even cards, right? Probability of even cards is what? 20 by 52 or 10 by 26, correct?
Yes,
Now that host has told me that I even, the number that I have picked, the card that I've picked is red. All right. What I want to ask is that will this thing change my beliefs about A, about the probability of occurrence of A? A is what? Getting an even number. All right. Now we calculated, now our new sample space is this one, correct? Our new
yes,
sample space has only red cards because my host has told me that it's a red card only. Now knowing that it's a red card, all the probability will be determined using this sample space only of 26 cards. Do you agree
yes,
with this?
yes,
All right.
definitely.
And out of these, I have only 10 even cards, right?
Hmm.
So my
Yes,
updated, now if somebody at second step, if somebody will ask you, Rishabh, what do you, your name is Rishabh, right?
yes, yes, yes.
Yeah. Rishabh, what do you think now? What are your chances? What are your odds of winning? So you will say, okay, total outcomes are 26. Why there are total 26 outcomes? Because the
Red
host
card
is
to
told
26.
it's going to be a red card, right?
Yes,
And then what are my odds of winning? I can win it 10 ways, right? One of the
yes,
10 number, if one of the 10 number comes, I will win. All right. And this apparently it's coming out to be 0.384. All right.
yes.
This is how independent events are defined, although they don't look different. And actually, whenever we think of independent events, we we end up thinking about mutually exclusive events most of the times. All right. So this is how the independent events look like. And if you want to find whether P given A, sorry, P of A given B is whether A and B are independent or not, so this would be equal to this. Also, I can also say that if, let's say, I want to see if the probability of B changes when A is given, when I have some information of this, if they're independent, then this will actually be equal to probability of B.
But
Why? Because they are independent. I mean, that's what empirically the result is showing us.
yes, but
And how you would actually calculate the independent events.
Yeah, but it is just a coincidence, right? Because actually being a red card actually is affecting the probability of even numbers. But because it is directly getting half, that is why the value is coming equal. But actually they are not independent, because when you are taking red, the value is getting half actually. So they are not. It's not like it's not affecting. It was just being.
So what happened is your sample space also turned up half. Now, I understand what you're trying to say. I understand that you're saying that it's coincidental that all of these values, like, both of these values came out to be same. Why it happened? Because the sample space also reduced to half, right? Now, I understand what you're saying, and what you're saying is correct, right? But I'm saying that the mathematically, they're defined in such a way that this would be called an independent event. Okay. Now blame the mathematics. The independent events mathematically are defined like such.
Okay. Okay. So
we would count it. So I would say maybe let's say that this wasn't 0.384. Okay. What you've learned now is how to calculate conditional probability of PA given by B. All right. That's what you've learned properly, right? Yes, let's just imagine that you would have taken some example where 0.384 wouldn't have happened. All right. Best case, you wouldn't have concluded that these are independent events, but do you understand the process of calculating the conditional probability? I think that is what is important here. All right. Because we can we can take up some other example wherein the probability might not come same. And it's okay. Yes, right. Yes. Do you understand the process of calculating conditional probability? The gist here is that the sample space reduces here. All right. We not just the desired outcomes get reduced, the sample space also get reduced. The only thing happened in this case, apparently, is that the sample space also got halved, and the favorable outcomes also got halved, and they came out to be equal. Which I understand from your intuition. Yes, it will affect, but independent events are defined in mathematics like this. Okay, so we will right away call them as independent events.
Okay, so as long as P, the value of P/B that is affecting the B, the condition B is equals to P, then it is independent event, no matter what's how it comes. But as long as it's equal, then you can say that it's an independent event.
Right. So it's logical, right? Like, think about it. I'm saying I had a probability A. I had certain beliefs about A. And then I got to know something about B. Are my beliefs about B, A getting affected? No. My beliefs about A still remain same. Okay. All right. Yes. It still remains same. If these are equal, that means A is independent of B. Correct?
Yes.
Just again, I don't know how it. I think again I should say that I might have taken an example wherein this would be different. I don't know why it happened again. We checked it multiple times this time. I think we ended up taking another example like such. But is the explanation clear?
Yes, definitely.
Explanation clear to everyone. This was like a big lol, I guess. Let me take some questions. Okay, I'll take up another example of conditional probability. Don't worry. I'll take up another example of conditional probability. Right, right, right. Shubham, you're right. I'll add some example. I'll discuss one example. Don't worry, don't worry. I'll discuss one example. Our sample space is changing, but is just turning out to be same, and that is why we are calling it independent event still. I'll discuss. Don't worry. As long as you're clear about conditional probability. Conditional probability, how do you calculate conditional probability is all you need to remember. All right. So P given A, B. Here we basically reduce the sample space to what exactly B has. All right. And from this, we make probability of A, we calculate probability of A. All right. So whatever is A here, and then we divided it with basically the sample space, overall sample space that we take is of B. All right. Can we extend this example? Let B be even that the card number drawn is a numbered card. All right. Have you tried, Pratik, if this works? Have you tried? Okay, okay. Let me just try it. So, Pratik, can you just come on the stage? Maybe if this example is working, I can just take it up. But I'll just call you on stage to like help me with uh, the example, understanding the question, and then I can just explain. Hi, Pratik.
Hi, Anand. Yeah.
Hi.
So,
Yeah, so
let
I
the
think I
event
would just require help with knowing the question, and then maybe I can just explain.
let the event A be the same, uh,
Okay, what is the event? Even number, right?
even number, and let
Mm-hmm.
event B,
Hmm.
uh, let that be that the drawn card is a numbered card. That is the
Okay.
additional information that we have.
Even this would actually become an example of how what we did in the last class, if you know, because even number would be actually a subset of numbered card. Do you understand my
Yes.
apprehension? So this would
But
actually become a case of what we discussed in the last class.
but this in this case we would get I mean the sample space and the favorable outcomes
Mm-hmm.
would change, not in the same ratio. So I think the
Got
probability would change.
answer will be different. Answer was actually anyway different in the last class as well. The only
Yeah.
thing is my apprehension is even number is a subset, which is what is happening in the last class. So it okay, all right. I think let's do it. At least they'll get one perspective. And since we are making it real world, so we are ended up taking not so idealistic examples as well. So let me just start. All right. So we have two things here. We have even numbers and we have numbered card, and of course there'll be a clash. All right, so numbered card here would be all the possible numbers and even number will be a subset. All right, so this would rather actually look like this. But there are other set of cards which are not numbered, so let me just make it with this. So how many numbered cards do we have? We have 40 numbered cards, right, Pratik?
Right.
And we'll have what, 12
12.
non-numbered cards, right?
Yes.
And then we have how many even number cards? We have 20 even number of cards. All right.
Yes.
So what is the probability of A by not knowing anything? All right. So we have 20 possible even number of cards and then 52 possible cards. The probability of A without knowing anything would be 20 by 52. That's correct.
Correct.
Now I know that B has happened. What is B? B has happened. It means our sample space has reduced to only, oops. Our sample space has reduced to what? To 40 cards
40.
only. All right. And then we have 20 cards. All right. Now, what is the probability of A now, which is what? An even card. How many favorable outcomes? We have 20 favorable outcomes. How
Right.
many total outcomes? We have
40.
40 outcomes total. All right. So the probability changes here. That's correct. but I just didn't want to take up this example because even number is a subset. Actually, this is exactly what was happening in the last class as well, which led to confusion.
In the
Um,
last class, the two sets were disjoint. The
no,
card being a numbered card, and the card, we took the example of a card being a face card, right? The other condition was the face card condition.
not a face card. It was not a face card.
Okay, not a face card. Okay.
Yeah,
Yeah, so
otherwise, though,
basically the
had it
same
been
condition.
point, then though it would have been like,
Right.
right away a no answer, right? It would
Right.
have been zero, right? Like, I mean, same, right?
So yeah, same
So,
example as the last class.
yeah. I think probably as Arijit was saying, more all the examples that we are coming up probably with these cards are turning out to be like, giving the same sort of answer or like, just acting up a little weird.
Yeah, so but this shows that how the conditional probability changes, and I feel that
Correct,
it's
correct, 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 correct,
uh,
correct, correct. And we'll talk about the formula as well. But guys, give me a thumbs up if you are now. I mean, I know I myself also got confused what is happening here last time. But is it clear now? Is it clear knowing that the sample space change and the conditional probability will be different? At least you're aware. Sadly, we are taking very real world examples in a real world use case. Can you explain independent events once again? Independent events, if let's say A and B are two given events, independent events will be defined in such a way that P of A given B, which means what would be the updated probability of A given I know something about B actually remains same as P of B. It can be defined in another way. What would be the probability of B given that I know something about A? It shall also remain same as B, probability of B. So if the probability of certain event that we are interested in doesn't change or remains same by knowing anything about other event, A and B would be considered as independent events. I'm just worried when will I be able to discuss Bayes' theorem? All right. So very quickly, I actually wanted you to sort of practice this question, but now just because we don't have a lot of time, let me do some practice and just tell you the answer very quickly. All right. So let's think of a manufacturer. All right. There is a manufacturer. So I'm going to speed up a bit here. All right. And maybe I can just do a revision in the next class. All right. So I have a manufacturer here, and which manufactures what? It manufactures chips. All right. This was supposed to be a quiz question. All right. And by default, I know that 2% of the chips that I manufacture are defective in some way. All right. Now, an inspector comes to my factory for the inspection. All right. And he selects 4 different chips. 1, 2, 3, 4. All right. He would select 4 different chips. All right. So first thing, let's figure out what is the event here. Event is, let's say chip is not defective. All right. Let me maybe mark this with 0.98. All right. So 2% is the probability of chip being defective. So I would say, let me actually just not use A. I will say P of defective is, I'm doing it a bit rushed because it's an obvious thing. All right. So you can just go back and watch the video again just to save upon time. So P of defective would be 0.02, correct? P of not defective would be what? 0.98. All right. 0.98 will be the probability of a chip not defective. All right. Now, what I'm interested is in knowing what is the probability of all 4 not being defective. All right. Or I can also say it as probability of at least 1 being defective. All right. This will come in assessments. All right. And all you need to remember is that these 2 things are same. All right. What you will be given would be this. they will say, tell us the probability that at least one of the chips is defective. All right. So if we have one, God, I think the problem has happened again. What's the time? 11:47. I think let's discuss this. I think we are left only with Bayesian Bayes theorem. That will take another half an hour or so, or maybe 45 minutes. I think we can discuss this in the next class. I might not be able to, I don't know if you are listening or not. Again, the same problem. I am not, my mouse is acting up, my trackpad. So I cannot even switch to the chat window and even like see your chat, what you are replying and whatnot. All right. So I think the probability idea was clear. Conditional probability, joint probability, and marginal probability. All three of them were clear. And we discussed about experimental probability as well. We discussed mutually exclusive events. We discussed joint probability. We discussed independent events, and all of this is clear. I think Bayes theorem and some bit of practice is left. What I wanted to ask you is that is it okay? Is it okay if I probably schedule 1 hour of extra class on Saturday just to like catch up? I am working with the Apple Pencil. I'm working with the Apple Pencil only. I don't know. I think it's just my days are not good. This is like the weirdest problem I can imagine. Weekday might be better, Sunday would be better. No, there'll be other classes as well. There'll be other classes as well. Actually, I'd like to do it on a weekday only because so that you can finish these questions very quickly. So I'll probably have a 1 hour class tomorrow. Please manage. Otherwise, those who cannot find time, please just watch the video. It's a humble request. I tried finishing off everything with time, but it just this thing took a lot of time. All this. What time? 9 p.m. only. 9 p.m. Otherwise, you can watch the video. All right. Okay, guys. Thank you so much. I am again sorry for the technological glitches. I tried my level best, and I'll see you hopefully tomorrow. Hope it was not too problematic like last time. All right. Okay. I think thanks a lot then. I'll see you. And I am not sure. I think the only way I can end this meeting is by switching off my computer. I can't even close this tab in my trackpad. So maybe you can just drop off. Tomorrow 9 p.m. Yes. Thanks. Thanks a lot. Yes, Saurabh, I think ideally we would like to do that, but there'll be students who will create havoc if we don't finish it in 7 months or 8 months, whatever. We are anyway, we'll finish it in 8 months, but I would love if you can allow us, all of you can allow us 10 months. That will be great. That will be amazing. All right, all right. Thank you so much. Thanks everyone. Bye bye. Please drop off, and I'll just shut my laptop in some time. I can't do it apparently. Oh, still there are people doing something.